Hi AP Calculus students. We are going to learn about an AP review topic today that is motion. So motion is a big topic, and as you can see by these notes problems, they're both listed with a calculator, so that is a common thing, but keep in mind anything could be on the calculator portion or the no calculator portion of the test. So a few things that I want to go over with you before we jump right into this problem is kind of reviewing some things that we've talked about earlier this year. A position equation can be represented by S of t or x of t or y of t. This represents what's known as rectilinear motion, which is motion along a straight line. So we're not talking about going off at different angles. This is very basic linear motion. So S of t would just be along some axis in space. X of t would be along the x-axis, so you're moving left and right. And y of t would be along the y-axis, so you are moving up and down. So the derivative of your position function, in whichever form you see it, is going to give you your velocity function, and the second derivative of your position function, which is the derivative of your velocity function, will give you your acceleration function. So you can also kind of go backwards there. If you were to integrate your acceleration equation with respect to time, the result would be your velocity equation. And if you integrate the velocity equation with respect to time, the result would be the position equation. So that kind of helps you kind of go back over where everything belongs. Now, this problem is a calculator problem. It says a particle moves along the y-axis, so we're going up and down, so that its velocity, v, at time t greater than or equal to 0, so they're telling us time starts at 0 and goes up from there, is given by v of t is equal to 1 minus the inverse tangent of the quantity e to the t power. At time t equals 0, so that's the starting time, the particle is at y equals -1. Note the inverse tangent of x is equal to the arctangent of x. They often put this on problems because some textbooks list it as inverse tangent and some list it as arctangent, and they just want to make sure that you understand those mean the same thing. The AP commonly uses the inverse tangent notation, but they're just tying those together. So when I have a problem like this, the first thing I do, since it's a calculator problem, is go into y equals in my calculator and type in this given velocity equation. So I've got 1 minus the inverse tangent, so second tangent, of e to the power of t, which I'm using x for time. All right, so that's in there now. And definitely you want to make sure that you are in radian mode. So for part A, it says find the acceleration of the particle at time 2. Well, this is our velocity function. So what do we do to velocity to get acceleration? Acceleration is equal to the derivative of the velocity. So we're going to say v prime of 2 is how we're going to do this. So in the calculator from the home screen, I'm going to hit alpha window and choose option 3 for n deriv, which is taking the derivative, d dx of vars, y vars, function 1. So I've already typed in the function. I don't need to type it in again. And then x equals 2. And then the result is -0.13290113335. We need answers rounded to 3 decimal places on every AP calculator problem. So 1, 3. This next number is a 2, but the 9 would round it up to a 3. So we want the answer to be negative 0.133. Now on this particular AP problem, keep in mind every free response question is worth 9 points total. For part A, they only give you 1 point for the answer. However, you are required to write down a derivative whenever you take one. That's part of required work. They're just not doing a work point on that particular part. Okay, part B. Is the speed of the particle increasing or decreasing at the time t equals 2? Give a reason for your answer. So speed increasing or speed decreasing is going to relate back to your note card, speeding up or slowing down. So if you will remember from your note cards, which I know you are studying very diligently right now as we get close to the AP exam, your speed is increasing if the sign, like positive, negative, SIGN, if the sign of your velocity and acceleration match, so both positive or both negative, and your speed is decreasing, you're slowing down, if the signs of your velocity and acceleration are opposite, so one positive and one negative. So we already know at time 2 that the acceleration is negative. So now we just need to check what is the sign of the velocity. So the velocity at time 2 is what we need to find. So in my calculator, since I already have my velocity equation in there, I'm just going to go vars, y vars, function 1, and then I'm going to evaluate it at 2. So when you do a function from your y1 menu and then parentheses and a number following it, it's like saying f of x, f of 2, or whatever. This notation tells the calculator to basically plug in a 2 for your x or your time here and find the result of that velocity. So this gives us negative 0.436. Negative 0.436. Now, we notice that the acceleration and the velocity are the same sign. So that means that it is increasing. Always answer the question asked. And the reason is because a of 2, the acceleration at time 2, is negative, and the velocity at time 2 is also negative. You can write that in words or in mathematical symbols. Those are used interchangeably on the AP exam. So for this particular part, B, of this AP free response question, they only awarded 1 point for giving the answer, which is increasing, along with the reason, and the reason is that both the acceleration and the velocity at time 2 have the same sign. Okay, part C. It says find the time for t greater than 0, greater than or equal to 0, at which the particle reaches its highest point. Justify your answer. So highest point is like an absolute maximum. So we've talked about how to find absolute maximums. You're going to use that good old candidates test, where you take your derivative, set it to equal to 0, find your critical values, create a table that includes both your endpoints and any critical values in between, and then check the y values for each of those times to see which is the greatest. In this case, since we're finding the highest, you could use the same methodology if you were finding an absolute minimum by finding the smallest number in the table. Both will be there. So our we're trying to find the highest point, which is the absolute maximum position. So the derivative of the position is velocity. So that's what we're going to set equal to 0 to solve for. And so we already have this velocity equation in the calculator. And so if we go to our window and say, I want my x-min to be 0 and my x-max, we really don't know how big it needs to go. We'll just start with 10 and see what happens. We're looking for zeros. And this window is not good because my graph is all squinched up next to the x-axis and I have all this dead space. So I want to kind of crunch down on that y-axis and say, maybe I only need to go like from -2 to +2 so that I'm a little closer in and I can see what's going on. So it definitely looks like we have an x-intercept very close to the y-axis over here on the left. So we need to know what that value is. So we're going to go second trace button for calculate. Oops, sorry. I think I hit, whoops. Second calculate. There we go. I think I hit alpha trace instead of second trace. We want the 0, number 2. So it says left bound. So your calculator says, show me the left side of the 0 that you're trying to find. So you're going to use that left arrow button and get over there on the left side. How do you know when you're on the left side? Well, you need to have a positive y value because it's going to be up above over here. So I can see 0.1, that's a positive y value. I'm going to press enter. Now right bound, it's saying where's the right side of the 0 that you're trying to find. So right arrow over here to the right. I'm in the negatives now. I know I crossed over the x-axis, so I'm going to press enter. These little arrows up at the top indicate where the calculator is looking for your 0. A lot of times there could be multiple zeros, so it can only find one at a time. It says guess, question mark. We don't want to guess. We just press enter. And there's the 0. Now, the graphing calculator automatically stores this x coordinate as x in the calculator now. So we will be able to use that, but we do need to write it down on our paper. So we're going to make our little table. Time is the independent value, and we're trying to find the highest point, which is the position y of t, or you could say s of t. Either one is fine. They really haven't defined the position equation, but we do know this particle is moving along the y-axis. So the endpoint would be 0, and they did tell us in the prompt that when the time is 0, the y value is -1, so this was a given. Now for critical values, we only have one, and that's the one we just found, 0.44302272. You're not absolutely required to write down all those decimal places, but you are required to use all those decimal places to calculate your answers. And then what about the other endpoint? This goes not between t equals 0 and t equals some other value. It just goes on forever. But notice this is the graph of the velocity. The velocity is negative. So for infinity, this thing is going down, 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 down. It has a negative velocity. Negative velocity indicates the direction of travel. It's going down. So since the velocity is positive for the t values from 0 to 0.443, and then the velocity is negative for t values greater than 0.443, we know that it can't be anything beyond this. Your lowest point is either going to have to be at your endpoint on the left or your critical value alone. Those are the only two possibilities. So, which one is it? Well, how are we going to know what the y value is, the position is, given we don't have a position equation? So the way we're going to do that is we do have a velocity equation. The integral of the velocity is going to equal the position. Of course, we do have to add that starting value. So y of I don't think you can see what I'm writing, 443 is going to equal my starting initial position, -1, plus the integral from 0 to 0.443 of the velocity equation dt. And we can do that in the calculator. So from the home screen, we'll type in -1 plus alpha window Number 4 for function derivative, start at 0, and I'm not going to put that rounded in value. I'm going to hit x, which is going to bring that last value that I calculated in my graph for x, the x coordinate of the 0, into that upper limit of integration. Then I'm going to hit bars, y bars, function 1 dx, and compute that value. So it's negative 0.953. And it's just going to go lower from there. So when is it at its highest point? It's at its highest point right here. Think of it in terms of money. If you owe somebody $1 or you owe somebody 95 cents, which one's better? This one. So this is the highest point. And we need to answer the question asked, find the time when it reaches the highest point. So the time would be 0.443. And that is the final answer to the problem. We don't have to complete this end part of the table. We actually cannot, because it just goes lower and lower to infinity. But this that we've written down here describing the behavior of the function takes care of that for us. So how do they score this problem? This part C is worth 3 points total. You get 1 point for writing v of t equal to 0 in your work. But you have to find this critical value, and the only way you can find a critical value is by setting a derivative equal to 0. So that has to be there. You get 1 point for identifying 0.443 as a candidate. So even if you got the answer wrong, but you noticed 0.443 was a candidate, you'd get a point. And then you get 1 point for your complete justification of the absolute maximum. And of course, that last point's hard to get because all the work that I have shown here is required. I haven't shown anything optional to get that complete justification point. Okay, part D, it says, find the position of the particle at the time t equals 2. Is the particle moving toward the origin or away from the origin at the time t equals 2? Justify your answer. So we just wrote a position equation on part C. So we're going to use that position equation to find the position at time 2. So that's going to take care of this first sentence in this portion of the free response problem. So y of 2 equals negative 1 plus the integral from 0 to 2 of v of t dt. And so that was actually the last thing I typed into my calculator, so I'm going to hit second enter to pull it back up, and I'm going to cursor over here where the x is, hit delete, and replace it with a 2, and press enter. And here's the answer for that. Negative 1.36, and that 0 is going to round up to a 1. So there's my answer for this first statement. Now the next question says, is the particle moving toward the origin or away from the origin at the time t equals 2? Justify your answer. Okay, what you need to notice is at the time t equals 2, the position is negative. So where am I located? I'm down below the x-axis. I'm on the y-axis, but I'm down below the x-axis. And what do we know about the velocity at time 2? It is negative. That indicates direction of travel. We're moving down. If we had a positive position and we were moving down, we'd be going toward the origin. But we have a negative position and we're moving down. So we're moving away from the origin. So we're going to say moving away from the origin. And it says justify your answer. So I'm going to say because my position is negative and my velocity is negative. You have to cite the signs of both of these to justify that answer because there's a lot of different scenarios you could have depending on whether you're starting above and moving down or starting above and moving up, starting below, moving down, starting below, moving up, in determining whether you're going toward or away from the origin. So both of those signs come into play here. All right, moving right along. Oh, and the point scoring here. This is worth a whopping 4 points on Part D. You get 1 point for writing down this integral in your work. You get 1 point for showing that you've added a -1. And you get 1 point for this answer. And then you get 1 point for saying away from the origin and supporting that with a reason. So there's a lot of points on here. And notice, even if this last part confused you, you could have still gotten 3 points just for this part. So keep in mind, show every integral, and you know, if you're adding an initial condition on there, a starting value, put that in there. Definitely give all your work for that, because that can rack up to a lot of points. All right, we're moving to this next one. It says a particle moves along the x-axis. So this time we're going left and right, so that its velocity v at the time t for time values from 0 to 5 inclusive is given by v of t equals the natural log, of t squared minus 3t plus 3. The particle is at the position x equals 8 at the time t equals 0. So the first thing I'm going to do here is go into my calculator. And I've messed a whole bunch of stuff in here. I've stored numbers, I've changed windows. I'm going to hit second plus 712 and get everything set back to starting. Go to y equals and put this new velocity equation in. So natural log of x squared minus 3x plus 3. Okay, enter your equation once and never again. Just enter it carefully so you're sure you got it right. A, find the acceleration of the particle at the time t equals 4. Well, if I have a velocity equation, I take its derivative to find, I want to put a 4 in here. You take its derivative to find the acceleration. So the v prime of 4 is going to be the answer here. And so from my home screen, I'm going to go alpha window, number 3 for function derivative, d dx, vars, y vars, function 1, x equals 4, enter. So this is the answer, 0.714. Part A is only worth 1 point for the answer alone, but you are required to write the derivative you took if you took a derivative. Part B, find all times t in the open interval from 0 to 5, so we're not including the endpoints here, at which the particle changes direction. During which time intervals for 0 less than or equal to t less than or equal to 5 does the particle travel to the left? So, how do I know if a particle is changing direction? Well, your velocity tells you the direction of travel. If your velocity is positive, it's moving to the right. If the velocity is negative, it's moving to the left. So it's going to change signs. Well, it can only change signs if it equals 0, because it can't switch from positive to negative without going to 0 between when we're working with a continuous function, which we are. So what we want to do is find the zeros of the velocity function. So I'm going to hit graph. And I really don't need this much space on here because I only need times from 0 to 5. So I'm going to go window, x values from 0 to 5. Y values, we could go, I don't know, -2. It looked like there was a lot of room. Oh, I need to cut off some from the top too. Let's say maybe 1, 2, 3, 4 to 4 maybe for my Y max. Try that, see what that looks like. Oh, that's better. I can see what's going on really well here. Okay, so when does my particle change direction? It changes direction when it changes signs. It changes signs twice, so I've got 2 times where it changes signs. I need to find those zeros. So I'm going to say v of t equals 0. You are allowed to use your calculator to find zeros, but you have to tell them how you did that. You're setting this velocity equation equal to 0 by using your calculator in this graphing utility as a tool. So we're going to hit second trace, find the 0, which is number 2, left bound. So we're going to arrow over here to the left side of the first 0. And there it is, press enter. Now it makes this little arrow up here, says I'm going to start looking right here. Well, we can't go all the way to the end because there's 2 zeros there, so we're going to arrow right bound to the right side of this 0. We know we're to the right when we see negative y values. We're going to press enter, guess, hit enter again, and it's just at 1. It looked kind of like that from the graph, but we verified it, so the time equals 1. And is there another one? Yes, there is. It's this other 0. So we're going to calculate that one. Second trace, 0, left bound, just get to the left side of it, press enter, right bound, get to the right side of that x-intercept, press enter. We don't care about guessing, press enter again, and that equals 2. Looked like it, but we are sure now. So the times of 1 and 2 are when the particle changes direction. Now, during which time intervals from 0, how did we know? It didn't ask us how did we know, but it's always a good idea to say. The particle changes direction when v of t changes signs. Okay, so during which time intervals from 0 to 5 does the particle travel to the left? Okay, so right is positive velocity, left is negative velocity. So when is my velocity negative? That's when it's underneath the x-axis. So that's going to be from positive 1 to positive 2. So it's going to be the interval from 1 to 2, during which time interval, so I've answered with an interval. Does the particle travel to the left? So the particle travels left. And I'm going to say because the velocity is negative. All right, that part B is worth 3 points. Wow. So you get 1 point for setting v of t equal to 0, 1 point for saying the direction changes are at times 1 and 2, and 1 point for giving this interval with a reason. Notice in the problem it didn't say give a reason for your answer. It just said during which time intervals from 0 to 5 does the particle travel to the left. It never said give a reason for your answer, but they have the point saying it's got to have the interval with the reason. So always justify your work on the free response section of the AP exam. And keep in mind that the best way to justify your work is always by quoting something on a note card or referencing some mathematical property that you have memorized from your note cards. They're not asking you to tell a story. They just want to know the math behind it. And the math is, all the math you need to know is written on a note card. Okay, part C. Find the position of the particle at the time t equals 2. So we have a position equation. I'm going to call it x because we're moving along the x-axis. So x of 2 will equal. We want to start with the initial position, which was given in the prompt at time 0. X is 8. So I'm going to put 8 plus the integral from the initial time 0 to the final time 2 of the velocity function dt, because if you'll remember, integrating your velocity gives you your position. And that's all I need. I just need to type this in the calculator now. So I'm going to go back to my home screen, and I'm going to hit 8 plus alpha window, option 4 for function integration, 0 to 2, of vars, y vars function 1 dx. And press enter, and the answer is 8.369. 8.369 is the answer. Now, D says find the average speed of the particle over the interval from 0 to 2. Okay, average speed. You have two note cards that say average on them. There's average rate of change and there's average value. If the problem is about average rate of change, it's going to say average rate of change. This says average speed, so this is an average value formula. Hopefully you have that formula well memorized now. It's 1 over b minus a. This is a, this is b in the time intervals, so it's 1 over 2 minus 0 times the integral from a to b, so 0 to 2, of whatever function it is you're trying to find the average of. Here we're trying to find the average speed. In your note card stack, you have a note card for speed. Speed is the absolute value of the velocity. So we put that as our integrand. And we type this in the calculator. So, clear this out. Alpha y equals number 1 to get my little fraction here. 1 over 2 minus 0. Now that was not really necessary. I could have just typed 1/2 or 0.5 even. But we've got it just like this. Now I'm going to put alpha window number 4 for function integration 0 to 2, and then as my argument of my integral I'm going to put the absolute value of the velocity. So absolute value you can get to about 3 different ways in your calculator. I like to hit second and then the 0 button to go into the catalog menu, because the catalog menu under second 0 has every function that your calculator performs in alphabetical order, and the ones that are not alpha are at the bottom, or you can just push up and you'll get to the bottom. So if you ever lose something in your calculator, this is a good way to find it because everything's in here. And the reason I like to go here is the very first one is ABS, which stands for absolute value. So I'm just going to press enter. My little absolute value bars are now on my screen. And now I'm going to hit vars, y vars function 1. So there's y1, because my velocity function is already in my calculator, dx. And then the answer is 0.371. Now, if your calculator gets hung up in calculating these integrals and it's kind of moving slow, you see that little thing rolling at the top right of your screen, that means your batteries are getting low. And that is one of the reasons that I recommend putting brand new fresh batteries in your calculator going into the AP exam, because your calculator does compute faster with fresh batteries. Okay, so 0.371 is the answer here. And this part is worth 2 points, 1 point for the integral. So when it says the integral, that's including the limits and the integrand, and 1 point for the answer. Did I go over the points on part C? I don't think I did. So on part C, it was worth 3 points. It was 1 point for the integral, 1 point for the initial condition, which means the +8 in front of it, and then 1 point for the answer. And that's it. So you've got a few more practice problems to work on here in this packet to get you ready for your AP exam. Let me know if you have any questions at all, and y'all have a wonderful day. Thank you.